Welcome everyone, and thank you for taking time from your busy schedule to attend this webinar on this important topic. Again, this is your moderator, Subbu Sankara. The topic on hand today is building in quality, the beauty of behavior-driven development. In software engineering, behavior-driven development is a software development process that emerged from test-driven development. Although behavior-driven development is principally an idea about how software should be managed by both business interests and technical insight, the practice of business-driven development does assume that the use of specialized software tools to support the development process. Behavior-driven development is largely facilitated through the use of simple domain-specific language, also called DSL for short, using natural language constructs. Example like English-like sentences. So that is the beauty of behavior-driven development. So now to the introduction of our guest speaker, Larry Apke. So simply put, behavior-driven development, giving the software that behaves that the users expect. Once again, thank you for attending this webinar, and I assure you that your next 1 hour will be well utilized listening to Larry Apke, learning about behavior-driven development in some level of detail from our guest speaker. Again, Larry Apke is a proven leader in agile development, agile coach, certified Scrum Master, certified Scrum Practitioner, and certified SAFE, so-called SAFE Agilist. A recognized leader in agile community, Larry is an expert speaker in various groups like Java Users Group, Scrum Users Group, etc. Larry is a highly accomplished visionary executive with history of technology and leadership and innovation. Worked at various companies offering and building products across multiple industries, including financial, education, healthcare, and aviation. Hands-on technical leader at managing software development lifecycle projects using agile techniques, building client relationships, and establishing effective long-term IT and operation strategies. So that's the introduction to Larry. While also some of the logistics for this presentation. While the presentation is underway, please feel free to enter any questions that you might have at any time. And I will try to bring it up, your questions at convenient pause points that Larry is going to give us during the presentation. So he's going to go through a slide deck. If we cannot answer your questions by any chance in this webinar, someone from Synergy will promptly follow up with responses at a later point in time. So with that, I introduce you to Larry Apke, our guest speaker today. Larry?
Yeah, thanks, Subbu. I appreciate that. One of the things that I tell people about my job is that I have one of the best jobs in the world because I get paid to help people. And it's through the knowledge and experience that I've acquired over the years. There are some times when I have information that would be of service to others. And that's the purpose of my being here today is I have quite a bit of experience with behavior-driven development. I believe it is an important thing to know and understand, and I want to share it with you all today. My goal is that this will be helpful to you in your everyday lives and that you hopefully will have some information on what it is and why we do it and also how we can implement it. My experience with behavior-driven development is interesting because as an Agilist, I believe in the Scrum framework, and we utilize that, and one of the things we have is a retrospective. And it was through a retrospective that one of my developers said, we should be doing this thing called behavior-driven development, and that was about 7 or 8 years ago. And since then, I have spent a lot of time studying it, trying to understand it, and now presenting it to others. The title, Building in Quality, is important because one of the people that I have a lot of respect for is W. Edward Deming. And if you're not familiar with him, he is kind of the grandfather of quality and I believe has a direct influence that can be traced to Agile. He says that quality comes not from inspection, but improvement of the production process. Now, he's talking about manufacturing, but when we look at the process of software development, a lot of what we call quality or QA is actually inspection after the fact. And the problem with that is we need to build the quality into the product to start. We cannot rely on mass inspection to improve quality. And Deming quotes Harold Dodge, who said, you cannot inspect quality into a product. The quality is there or it isn't by the time it's inspected. So the key for software development, if we're really concerned about quality, is we have to figure out how to build quality into the product as opposed to trying to find those defects that we built into the product and remove them. It's subtle, but it's certainly much, much different and much, much more important to understand how to build quality in. For me, the answer is behavior-driven development. But one of the things, before we understand behavior-driven development, we need to have a general understanding of something called test-driven development or test-driven design, which is TDD. For those who might not be familiar with it, I'm going to go quickly through what TDD is and its relationship with behavior-driven development. TDD starts by writing a failing test, which for a lot of people is counterintuitive, but we write a test and we validate that the test runs and that the test actually fails. That's what we call red. And then we make the test pass with writing just the minimum code that's necessary to make sure that the test passes successfully, and that is green. And then we refactor the code, both the tests and the production code, in order to make sure that everything meets certain standards. So when you look at test-driven development, it's the concept of red-green refactor. For me, it was, I remember when I first heard this, I was not exposed to it until about 10 years ago, and it seemed like a very strange concept of writing tests before we write code, because I came up through writing code, and I never was exposed to that. But there's a lot of reasons why we would want to do something like test-driven development. And test-driven development is something that came out of Kent Beck and the XP movement. One of the reasons is what are sometimes referred to as the ILDs. Test-driven development allows us to have a better chance at maintainability, flexibility of code, extensibility of code. It provides us with a high percentage of test code coverage, meaning that if we're writing tests for everything that we write in production, we're going to have a high rate of coverage. Now, the percentage of coverage as a number itself is not necessarily important, but it is directional in the sense that if I have only 10% of my code covered and I have another code base that has, say, 70% of my code covered by tests, we can assume fairly intuitively that code that has 70% coverage is higher quality code, but the number itself sometimes is misleading. Test-driven development, because we're only writing the minimum code necessary to make our test pass, it allows us to streamline the code base, and we do not gold plate or try to come up with things that we can do that the code doesn't need to do as of today. It provides cleaner interfaces because we are working at refactoring the code as we go along, and it makes refactoring of code so much easier because what we have now is as we go into code that existed and has test code coverage, when we refactor that code, we can be assured that the functionality continues to be the same as we would have expected, which is the concept of regression testing. So where in a lot of cases we do not want to do refactoring because it can cause us a lot of problems with regression defects, when we have a lot of test code coverage and primary test code coverage of our code, we can easily refactor that because we are less apt to be cautious because we know that our code is good. And the other thing that's really interesting about test-driven development is that the test provides some code documentation. If you can imagine the scenario where a new developer comes to a team and we want them to understand how the code works, because the tests describe the code, we can actually show them the tests and have them run the test, and they can better understand the code that underlies and is described by the test. The bottom line with test-driven development is if we do this and we have the discipline to do this, we have higher quality. It is something that we desire. It's building quality into the product.
So Larry?
Yeah.
This is Subbu.
Yeah.
In your earlier slide, you mentioned about high percentage of coverage. What would be a good number for high percentage? Do you want to comment on that?
Yeah, briefly, the number itself, like I said, is directional. So I have a funny story where we weren't allowed to put production, when I was a development manager, we weren't allowed to put production code in, put code into production unless our test code coverage increased with each release, which on the surface sounds great. Mm-hmm. But a lot of times that your code coverage can go down. It doesn't mean that the quality of the coverage exactly goes down. So we did a lot of tests actually on getters and setters, which increased our test code coverage, but it didn't increase the quality of the code. Mm-hmm. So getting trapped by the numbers is sometimes difficult. I would say that the key would be that any major portions of the test code is covered, specifically those that might have the highest complexity. So we can use static code analysis to give us things like cyclomatic complexity. I would certainly want to make sure that those things are covered. Those things with low complexity have less need for test coverage. So it's not the number that's important, it's really what we're covering and how that contributes to the quality.
Okay, very good. Thank you. Please continue.
So, yeah, absolutely. So I would assume that I see that there's roughly 30 folks on this webinar. I would assume, unless some of my friends have joined, most of you folks have never heard about me or heard from me before, which is okay. I can live with that. But one of the people that you probably have heard of is a guy named Bob Martin, Uncle Bob Martin, who is probably recognized as one of the most important people in code quality. He has a book called Clean Code. He has a couple other books. He was one of the original signers of the Agile Manifesto. The more I come in contact with Bob's work, the more I am impressed by it. And one of the things that I looked at is, if we want to talk about TDD, let's hear what he has to say. And one of the things that he talks about is that it's a myth we can get systems right the first time. Instead, we should only implement today's stories and refactor and expand the system to implement new stories tomorrow. This is the essence of iterative and incremental agility. Test-driven development, refactoring, and clean code they produce make this work at the code level. So basically what he's saying is we generally can't get things right. We need to be able to make sure that we have code that we can refactor easily in the future if we want to be agile. Test-driven development allows us to refactor. He goes on to say, and these are from his book, Clean Code, if the discipline of requirement specification has taught us anything, it is that well-specified requirements are as formal as code and can act as executable tests of that code. And this was written before behavior-driven development, but it talks to us about the fact that we can basically write the specifications and the requirements in code itself, and those can be executable tests. That is kind of the bridge to behavior-driven development, and we'll talk a little bit more about that as we go along. A lot of folks think that test-driven development is slower, but rightfully so. He says if you want to go fast, if you want to get done quickly, if you want your code to be easy to write, make it easy to read. The problem that we have with code, and anyone, if I have developers out there, they're well aware of this, is that it's much easier to write than it is to read. In fact, my son just graduated from computer science at Arizona State University, and they were taught to write code. They weren't necessarily taught to read it. It is so much more difficult to read code. Test-driven development, because we're actually writing tests that massage the code, it actually gives us more understanding of what the code does. It makes the code easier to read. And if we want to be fast, if we want to be able to make changes and refactor, we need to make the code easy to read. So test-driven development is something that will help us do that. It doesn't cost us anything in time, because if we want to go with quality, we go faster with quality than by not doing quality. In fact, we call bad quality code high technical debt code, and code that has high technical debt is very difficult to refactor. He says the ratio of time we spent reading versus writing code is well over 10 to 1. We're constantly reading old code as part of the effort to write new code. Therefore, making it easy to read makes it easier to write. And again, test-driven development and the code that it creates and how it describes the production code makes our code cleaner and easier to read. He also talks about what it means to be a professional developer. And I include this because I think it's important if we have any developers on this call to hear what he has to say about that. He says, perhaps you thought that getting it working was a first order of business for a professional developer. The functionality that you create today has a good chance of changing in the next release, but the readability of your code will have a profound effect on all the changes that will ever be made. So he's saying to be a professional developer, we have to be able to write code that can be read. It's not just enough to get it working. And he goes as far as to say, and I remind you, this is Bob Martin and not necessarily myself, though I agree with him. Programmers who satisfy themselves with merely working code are behaving unprofessionally. The professional developer should write clean code. And he goes on to say, writing clean code is what you must do. There is no reasonable excuse for doing anything less than your best. I would attest that there's other aspects of being a professional developer, including writing clean code. And those would be your code must be secure, it must be performant, it must be deployable, you must be able to integrate that with other code. In other words, code quality must be injected into the code by professional programmers. So when people ask me where the majority of the testing should be done as far as building quality into the code, it can only be done by the professional programmer. Quality cannot be inspected into the code ex post facto, meaning after the fact. I just like that. It sounds really nice, ex post facto. We cannot inspect quality into a product. We must write it into the product. Therefore, it is the responsibility of the professional developer to write quality into their code, and test-driven development is probably the best way to ensure quality is injected into the code as opposed to inspected after the fact.
Larry?
There are a lot of folks who, go ahead, Sabu, I'm sorry.
I just want to reiterate and encourage attendees to type in questions. You can type in questions anytime, and I'll suitably bring it up with Larry. That way, this webinar will be more interactive. I want to make it interactive, except that you'll be able to type the questions. I can bring it up. So just want to reiterate. Back to you, Larry.
Sure, absolutely. Thanks, Sabu. The question is, I can usually get developers to agree that test-driven development is the right thing to do. I haven't had that become a huge issue in my experience, and I've worked with thousands of developers over the years. But it's kind of akin to saying writing a book would be a good idea and then handing you a pencil and a piece of paper and say, go at it. There's a reason that people don't do it. Most of the developers have not learned to do test-driven development. They were not taught that way. So there's a learning curve associated with it. And again, my son who graduated from college, they do not teach test-driven development. I believe that to be one of the things in our educational system as far as educating programmers that we need to rectify, because we need to learn how to do test-driven development so that it becomes something that we do as a matter of course. Test-driven development is extremely disciplined. I'm not going to say that developers are undisciplined as a lot, but I think developers tend to like to tinker and they like to go right into coding. What we're asking developers to do in test-driven development is not to go directly into coding, but to actually think about the test cases, write the test cases, have those test cases fail, and then write the code that would allow them to pass. That is extremely disciplined, and there are a lot of folks, for whatever reason, who just do not have the discipline that's necessary, and it's something that needs to be learned. It's something that needs to be done on a regular basis. There is a perception that development is slower using test-driven development because we're writing more code and we're writing test cases up front. I believe it is a perception because I believe over time, if we look at the entire life cycle of software, the first time we write software usually represents 20% or less of the entire life cycle of the code. So the majority of our time is spent actually making enhancements and fixing defects to the original code. And if that's the majority of our time, as Uncle Bob says, is reading code and not writing code. So over the lifetime of the software, the development is actually quicker as we create higher quality software because it's easier to read and therefore easier to refactor, easier to enhance, etc. So it's just a perception that it's slower. And I don't think it's necessarily true. I think we need to combat that perception, but it does exist, and it is one of the reasons why folks don't do it. Another problem is it becomes difficult to introduce with legacy code. One of the things about using test-driven development is by its very nature, we're writing testable code. Now, that may sound kind of strange and obvious, but most of the time when we don't use test-driven development, we write code that may not be that easy to test. And because of that, most of us, unfortunately, don't get to start with the code. We usually end up in the middle of it, and we work with legacy code. So it becomes difficult to write tests for that legacy code because the code itself is not very testable. And the reason it is because in object-oriented programming, we probably have made some mistakes in the design of the code. One of the things we need to learn in addition to test-driven development is we need to learn, at least in object-oriented programming, how to mock out objects. And we need to learn how to effectively using mocking of the objects, because it's very often that when we're testing, we don't necessarily need to run the entire procedure. We just need to run the business logic. And sometimes we need to mock out objects in order to just test the business logic. And for some, there's a learning curve. And because of this, test-driven development really hasn't taken off as much as it probably should. Dan North, the one who invented behavior-driven development, saw this. He said, I kept coming across the same confusion and misunderstanding. Programmers wanted to do test-driven development, but they wanted to know where to start, what to test, how much to test, what to call their test, etc. And so what Dan North did is he invented something called behavior-driven development. And behavior-driven development it allows test-driven development to be more accessible. And the interesting thing about behavior-driven development, and we'll get into actually what it is, but I'm going to talk about why it works and how it came to be, and then we'll talk about behavior-driven development itself with some examples. But what they found with behavior-driven development was that over time, it's actually more than just test-driven development. As Sabu said in the introduction, behavior-driven development, and Dan North has said, it's grown to encompass a wider picture of agile analysis and automated acceptance testing. So what we're doing when we describe with this domain-specific language, the DSL, we're describing the behavior of the system. What they found is that we begin to create a ubiquitous language or a domain-specific language for the analysis process itself. It becomes a way to describe the work that we are there to do. And because we are using a language that everyone understands, what they found is that over time, the conversations between the business people who want certain behaviors in the system and the developers who are going to actually implement these wants, needs, and desires, that business communication and conversation and collaboration became much, much richer. And that's the real point of behavior-driven development, is that we started out trying to solve the problem of test-driven development. And what we found is we solved the problem of acceptance criteria. We solved the problem of business communication. I worked for I did consulting for a company in San Antonio, Texas, which I have an example of later. They used to call what the business people called what developers say, they called it dolphin speak. Because just like dolphin, they knew they were saying something, but they had no clue what they were saying. Behavior-driven development allowed business and development to actually speak the same language, and by doing so, gain a better shared understanding of the work. When we gain a better shared understanding of the work, we have a better chance of implementing. So the question that I want to answer first is, why do we do behavior-driven development? So if we think of TDD, TDD builds it right. It is the right process to build it, whereas BDD builds the right thing. If we're going to be successful in software development, one of the things that we need to do is not only build it right and do the right processes, but we also want to make sure that we build the right things. And BDD allows that. There is no silver bullet in software development, but I've been around software development now for 30 years. When you take behavior-driven development along with some of the DevOps practices like continuous integration, this is going to be as close to a silver bullet as you can find. And the reason being is, hopefully I will be able to convince you as we go along. The other point of evidence I have with why we do BDD and why it's important. I write a blog, and I've written over the years over 100 blog entries. And way back in 2012, so this is a long time ago, this is 5 years ago, I wrote a blog on 10 reasons why BDD changes everything. And by far, of all the 100 plus blogs posts that I have, this is the most frequented. And obviously, there's a great deal of interest in behavior-driven development in the software development community. So briefly, if you will, Sabu, if you have anything?
I just wanted to ask you a question. Is it easy to get started with behavior-driven development?
Yeah, actually it's very easy to get started. It is something that the folks on this call, if they wanted to start pretty much tomorrow, they could do it. And we start by changing the way we talk about acceptance criteria. I'll get into that in a little bit, but okay. Yeah, it's very, very easy. And I'm gonna lay out a plan later on the steps that it takes to actually implement this for those folks on the call who are interested in implementing it.
All right, thank you.
So, yeah, no, thanks, Sabu. I appreciate the questions. I'm going to go briefly through the 10 reasons why BDD changes everything from my blog to give you some more reasons why BDD is important. The communication between the business and development is extremely focused as a result of the common language, the domain-specific language. That is a huge benefit. Also, the business needs will tie directly to the code that is written. So if you can think of behavior-driven development, you can think of it as executable specifications. And one of the biggest holy grails in software development is this concept of traceability. Can we trace the quote-unquote requirements or stories to the code that's actually being written? You will see as I go through how BDD works, how you can trace directly from the business needs to the code that is written, which is a huge benefit. Developers know what test cases they should write to accommodate test-driven development, so the original purpose is still there. It allows us to do test-driven development, and because of that, we get all the underlying benefits of TDD more easily realized. Your code is much easier to maintain. It is self-documenting. One of the interesting things as I came into this world of software development, I came in through training and development and documentation. And documentation always lagged much behind the software itself and the functionality. And in most cases, even the documentation that we would have internally about software designs and architectures and things would be behind the code and would be outdated very quickly. When we use behavior-driven development, we're using human-readable English to write the executable specifications. Because of that, the human-readable English becomes the documentation of the code itself, because the human-readable English ties directly to the tests, which tie directly to the code. In an agile world, behavior-driven development makes stories easier to groom. They changed the word groom now to refine, but either way, if you're doing Scrum, there is a ceremony called refinement. And that is where we break down stories and we put tasks and we start planning those out. With behavior-driven development as acceptance criteria, it helps us with that process. If we find a lot of what we call BDD scenarios on a story, we can use those scenarios as means of looking at the story and figuring out where we might break that story if it's too large. It also helps us to understand the tasks that we need to do to accommodate and implement that story. By understanding both how to break down and task it, planning is easier. Because of this, teams can be more agile. I've found in my experience that if you want to be agile, there are probably two things that you need, and I have a presentation that I've given in the past about that. One of those is BDD, or some form of acceptance testing development, automated, as well as continuous integration and deployment. When you have BDD, your teams can actually be more agile and they can sustain agility over a long period of time. The other thing that was interesting is in my past career as a manager and director of software development, I used to have to hire and train developers. When you have behavior-driven development, because it describes the tests and the code, it becomes much, much easier to onboard developers because you can point them to human-readable documentation that describes the behavior of the system. There is also more visibility into the team progress and status. If I have, say, 10 different scenarios on a particular story, I can watch as those scenarios are written. I can watch as they fail, and I can watch as they pass. And it will help me to understand the progress towards completion of the work.
Larry?
Yes.
The questions coming in. You mentioned about self-documenting code. I know there is a product code and there's a test code. People write automated tests. So how does the code become self-documenting and easier to maintain and train new people coming onto the team? Would you be able to throw more light on that?
Yeah, I will as we go along, but basically the way it works is we're writing the BDD scenarios, the human readable first. So instead of writing documentation and tests after the fact, we're actually writing the documentation and tests first. So the BDD in human readable English is the documentation. It is written first and it's turned into tests. And then those tests are turned into code. So that way our documentation is always up to date because it's the documentation that actually drives the system. Most times we actually write the code, test, and then document. So we're flipping that. So that's why documentation should be perfectly in sync with the code.
Okay, so walking through the test code in human readable English like format makes it more, you can relate to what the code is doing and how it is going to behave.
Absolutely.
All right. Excellent.
Absolutely.
Once again, thanks, Larry. Once again, I encourage our attendees to type in questions anytime, and I'll be able to bring it up in this forum at suitable pause points that Larry is going to give. Back to you, Larry.
Yeah, thanks, Sabu. I wanted to, again, I think right now I'm selling, as salesmen say, I'm selling the sizzle as opposed to the steak. We'll get to the steak in a little bit. But I wanted to talk a little bit about some real-world examples of how I've experienced in my career BDD being effective. One of them was I worked for a financial service company in Scottsdale, Arizona. That's my hometown. I spent 25 years of my life in Arizona before moving up to San Francisco Bay Area. We had a problem in that we were having our business and analysts and product owners write stories for the team to carry out. And I don't think that's unusual. I would assume that some of the folks on the call have a similar situation. What we found is it was very, very difficult for them to express themselves with acceptance criteria that could be used and implemented by the team. And it was almost, the way I think about it is it was almost like there was a dark cloud hanging over the team, because they were having such a difficult time actually writing the stories and the acceptance criteria for those stories. We worked on behavior-driven development and taught them how easy it was to do, and it is very easy to implement. We implemented BDD scenarios. And when we started implementing BDD scenarios as acceptance criteria for our stories, it was as if the clouds parted and the sun shone again. Because we got to a point where we were so good at it that we were writing acceptance criteria on stories too far ahead in the process, and I actually had to tell them to slow down. So in this particular instance, just the ability to express the acceptance criteria using BDD scenarios allowed us to actually write better stories and give that work to the team. Another example was I worked for a financial services company in San Antonio, Texas. And I had the really, really good fortune of working with a wonderful team in what they called their innovation lab. And their mandate from the company, if I remember correctly, was to take things from proof of concept and get them into the customer's hands within 90 days. And this is something that, as far as I know, they were never able to do in the past. This was something that was new. And I had the good fortune to work with them. We decided to adopt behavior-driven and test-driven development as the way we were going to do the work. And what we found is that we were able to actually deliver the software into the customer's hands within 75 days on the very first project, which was 2 weeks ahead of time, and faster, as far as I know, than any time they were able to take proof of concept into customers' hands. So that was a huge win. The other thing that was really interesting is because we were so successful, we went on a little bit of a tour, a victory tour, so to speak, around that company and presented the BDD training to those folks who were interested. And it was developers who did it. It wasn't me. And the wonderful thing about the developers is they would tell a story that every time they felt that they could go faster by not doing the behavior-driven and test-driven development, these were the times that they ran into the most problems. So they got to a point where they understood how critical it was to have the discipline to always use BDD and TDD to deliver high-quality software. Any questions? Because I'm going to get into the steps now.
No, we are good. Please continue.
Okay, wonderful. So hopefully I've convinced you all that this is probably a good thing to adopt, if not at least consider adopting. And then the question remains, I want to do this, how do I get it done? And I've broken it down into what I consider 3 very, very simple steps. And they're in order of their importance, and they're also in order of their ease, because we want to start out with the easiest thing to adopt and then move to the most rigorous thing. And so the easiest thing we can do and the most impactful thing, in fact, if we had to talk about percentage of efficacy, this is probably more than half the benefit. And that's writing our story acceptance criteria using BDD scenarios. And we'll talk about those scenarios, and I'll give you some examples shortly. The second step is once we have these BDD scenarios, we can start to leverage these scenarios because they are actually test cases to write automated tests and start to do true test-driven development. The third step is now that we have the ability to write our tests first and do test-driven development, we are writing our acceptance criteria using behavior-driven development scenarios. Now we can leverage a tool like Cucumber. There's a tool for almost every language. So there's SpecFlow, Cucumber, Lettuce, a whole bunch of others, Spock, that can help us map this human-readable BDD scenarios to the automated tests, so that we're actually running human-readable testing. So step 1, writing acceptance criteria in BDD fashion. What we do is we get, during the story refinement process, we get together what is referred to by Dan North and Liz Keogh, the 3 amigos. We get our product owner, we get our developers and our QA people, and we get them into a room. And this is during story refinement. So we take the stories we're going to do in our next iteration if we're doing Scrum, and we start talking about them and putting detailed acceptance criteria on them. And this first step, as I said before, is the one that brings the most benefit. This was a surprising thing because Dan North was looking for better ways to do test-driven development. He did not expect that this would necessarily happen. But what happens is the communication is better, so the better communication equals better quality and ability to write it, implement. So what does BDD look like? It's so simple that my mother, who can barely send emails, and I love her to death, but she's not great with technology, it's something that she could understand, and you'll see why. First, we start with a story. So in this case, we're going to do an ATM story, and this is the same one that you would find if you did research and looked at the Dan North's website. The story is simple. As a customer, I want to withdraw cash from an ATM so I don't have to wait in line at the bank. We're going to write specific scenarios and behaviors of the system that would allow us to accomplish that. first scenario, let's assume that we have an account and that account has money in it. Given the account has money in it and the card that I've used is valid and the ATM dispenser contains cash, when the customer requests cash, then ensure the account is debited. Ensure cash is dispensed and ensure that the card is returned. So notice this very simple scenario. I'm going to draw your attention to the key words given, when, and then, and also and. Given is our setup. What are the things that are important about this particular behavior that I need to know? When is the behavior that happens to the system, and the then is the behavior we expect as a result of what happens to the system. And again, if you look at this, and usually at this point in time I can see people's heads nodding, but I think you can very easily see this scenario and understand the behavior that we're trying to get out of the system. One of the interesting things about scenarios is it's also multiple scenarios that are necessary to flesh out the behavior we desire. So you can easily see by this scenario some other potential scenarios, because scenario one is that the account is in credit. So we can assume that there's a scenario two, which is the account is overdrawn and it's past overdraft. And in this scenario, given the account is overdrawn and my card is valid, when the customer requests cash, what should the system do? Well, the system should ensure a rejection message is displayed and ensure that cash is not dispensed, and because the card is valid, ensure that the card is returned. So by creating these simple scenarios, anyone who might be on the call who knows anything about testing is these are basically test cases. So not only have we written the behavior of the system, but we've written test cases that will allow us to test the system. And this is something that the business can understand, and it's something that development and QA can understand. And that's the beauty of just writing our scenarios using the very simple words given, when, then. One of the things that I want to point out is usually you have the word and because we have multiple conditions. You usually only have one when because there should only be, like an experiment, one independent variable that makes a change to the system. So those are how we write BDD scenarios. I'm going to stop just briefly if there's any questions on the writing of the scenarios. I think it's pretty self-explanatory, but we may have some.
Thanks, Larry. We don't have any questions specifically on the writing, and we have some questions that we will take up at the end. So
okay,
you can
perfect.
Thank you.
So I want to move on to step two. Now that we've written these BDD scenarios, which are really test cases, all we need to do is we need to leverage these scenarios, and we can put them into our testing software. So I'm going to show an example using JUnit, and it's not if you guys are developers on here, it's not a great example, but you'll be able to follow along. So here's an example. On our first scenario, notice we do public class account is in credit and it tests and it extends the test case. And the very first part is our setup. And it's here we can take the scenario and use comments actually in the code itself to write the scenario into the test case. So we know what the test case is in human readable English. So you can see here these forward slashes are comments. So I've commented directly in the code the first part of the scenario, which is the setup. And what I would do, and the interesting thing about this is because it's test-driven development as well, it's telling me things that I need to know about the production code I will write. I know I need to have something called an account. So I may, in this scenario, as part of the setup for the test, mock out an account. I know that I need to have credit in the account, so I may add credit to that account, credit property to that account object. I know I'm going to have an object called a card. I'll need to mock that out, probably, and I'll probably need to set a property of that as valid. I'll probably need a dispenser object, and I'll need to make sure that there's some cash in there, so that there's a cash property to that. So you can see how this is helping me write the test itself before I've written any production code. And when I look further into the code, you can see that I can now take the when clause and put that in comment so that it doesn't execute, but I can see what I'm using to create the test. So the comment says when the customer requests cash. So I know that I probably want to create a method called customer request cash, and I'm probably going to give it some kind of amount. And this is my actual calling of that method, the when piece of it. And after the when, I'm going to do my then, and this is my at test piece. This is where I'm testing it, and I can again put in the comments, my then phrases, and in those I can make my assertions, like assert equals the expected account balance is equivalent to the account balance that comes back from the method. I can assert that the cash dispensed is true and that the card returned is true. So what I've done is I've taken this BDD scenario to very simply write a test case. And that's what it would kind of look like in JUnit. The third step, I'm going to keep going on, is we can start using a behavior-driven development tool which will remove the need to do the comments directly into the test code, but will allow us then to take the human readable scenarios, and it uses regular expressions to match those and map those to the unit tests we're creating. The other thing about a BDD tool, which is great for me because I'm not a great developer, I can do some, it creates a unit test shell, which helps us to create the test. I'll show you that in a second. And when the BDD tool runs the tests, we see the output of what passes and fails against the human readable scenarios. So it's something that if I showed it to a business partner, they would be able to read it and they would be able to see what passes and what doesn't. And there's BDD tools for all the major languages. If you're doing Java or Ruby, I would recommend Cucumber. So here's a scenario. Given the user navigates to the logon page, when they enter a valid username and password, then the logon should be successful. It's a very simple logon scenario. And what happens when I put it through the tool is you can see that the tool creates this shell file. And you can see on the given part, it's using these regular expressions. That's what the dollar strings and the other things are to map to the human readable English. And you'll notice that underneath that given piece, it will say, express the code above in the way that you wish. So I'll write my test into this part of the BDD tool. And you'll see that it's mapping with regular expressions the when clause and the then clause. So once this shell is generated, I can start actually putting in code that will correspond to the test that I want to write. So in this case, when the given part, the user navigates the login page, I'm going to go to a login page, and I'm going to create a Firefox driver because I'm doing this in a browser, and I'm going to navigate to the login page. So you can see how I'm writing a test here in this given piece to navigate to the login page. And once I get to that login page, I'm going to pass the username and password. And then this driver is going to take that email address, which is the username, and it's going to send it into the page. It's going to take the password, send it into the page, and it's actually going to click the submit button. So this is how I would actually massage the code and express it. And then the last bit, which I lost, is I would actually have a then clause which would make the assertions whether or not the expected behavior was what I expected to see. And when I run this test, I can run it from a command prompt, and what it will show me is that if it's successful, it will show the number of scenarios that were run and the number of steps that were passed and how long it took to do that. The problem with this is it's somewhat hard to read, and the more tests I have, the harder it is to read. So one of the things that we can do is we can use this Cucumber tool and show it in a way that's a little bit easier to see. So this one has a scenario of, given I have 30 products, and I should see 20 per page. And when I click on page 2, I should see 5 products. What you'll see here is if you're following down through here that there's an error in red, and it shows me exactly in the code what I expected to see and what I did actually receive back from the system. So this helps me to understand why the test fails and what I need to do to correct it. And you can see that it is in human readable English. Those pieces of the code that pass are in green. Those pieces that do not are in red. The last thing I wanted to get to, which is great because I know we're getting to the top of the hour and you have some questions, is the bonus step, and the fourth step is if we have a bunch of BDD tests, we can use a tool. This is a tool called Serenity that can take all of those BDD tests and put a dashboard around those BDD tests to show us the different tests are running and how they're running, and we can group them and we can do all kinds of things to show the health of the system and the tests that are running, the BDD tests that are running as a result of that. And for the most part, I have included some helpful links, and I know that this will be available to you so that you can check out some of these links to the tools and some of the information that I presented. And I know we have questions, and Sabu, you had some things you wanted to talk about as well.
Great. Fantastic. Thanks for the wonderful insights into behavior-driven development. We've come to the end of this presentation, and I encourage again everyone to keep typing the questions. We have already a few questions lined up that we will take up. In the meantime, Larry, if you can, I would like to give a very high-level 1-minute overview of Synergip, the sponsors of this webinar. So if you can move the slides to Synergip deck, that'll be good. It's a couple of slides there. Thanks, Larry.
Yep. Mm-hmm. I'm on the first one.
All right.
Bullet point.
Thank you. So this is so we are a trusted outsourcing partner for agile software product development. We focus on startup to mid-sized companies to do software product development in the cloud, mobile, and doing some wonderful projects in the big data, emerging technology areas like augmented reality, virtual reality, and other areas. We accelerate the delivery of your product roadmap. We address the technology skill gaps that your current products might have. And we plug in seamlessly with your on-site development team to help expand on the product roadmap. As a result of engaging with us to partner with your in your product development, there is a significant cost savings, and we guarantee at least 50% cost saving in using the offshore product development. And again, we work in a model where we can help you with on-site professionals by working alongside your team and running the rest of the team members with offshore. So this is sort of a 30,000-foot overview. And in this slide, thanks, Larry. In this slide, we capture the various customers that we had worked with in the past 10 plus, 12 plus years. So we have been helping many customers over the course of our journey. And if you have any specific needs to expand your product roadmap, product footprint, I will be happy to jump in and work with you to help. And can you move to the slide where you show my contact?
Yep. What's up?
Okay. So you can connect with us in many ways. So here are some of the channels that you can connect with us. And can you move to the last slide also? So next month we are going to do a, thanks Larry. Next month we are going to do it a little bit different. Instead of the webinar, we are going to have a in-person event in Dallas, Austin, and Houston areas. The schedules will be posted and are given here. So I encourage you to keep checking the dates, and if there's a schedule that would permit you to attend these events in any one of these places, we encourage you to sign up, and also encourage you to refer your partners, customers, acquaintances to attend. So with that, we have come to the end of the seminar. We have a few questions that have been queued. So I would like to take up these questions. The first question is test-driven development and behavior-driven development. Are they more like verification and validation testing? Can you throw some light on that, Larry?
Not 100% sure what is meant by verification validation testing. What I would call it is I would call it acceptance testing. Okay. It is the acceptance of the stories and the tests that we can run in order to make sure that the major functionality of the story has been expressed in the code.
Okay. Very good. Thank you. And at what point in the second question is what point in the software development process do you write business BDD scenarios?
Yeah, this should be in the story refinement piece. So if you're doing Scrum, it's easy because we should be having regular occurring meetings to do story refinement with the team, and it should include the product owner, QA, and developers in this refinement. If you're not doing Scrum and you're using something else, you would do it whenever you're refining those stories and breaking them down into acceptance criteria.
Okay, very good. And the last question is, if you're doing Agile Scrum techniques today in your product development with your engineering team, is it easy to migrate to BDD?
Yeah, I found it was easy. I think the hardest thing is actually deciding to do it. When I talk about the work that I did with the company in Scottsdale, I was working with a very brilliant person on the team, and his question is, when should we start? And I said we should start tomorrow, and we just bit it off and we started right away. But we bit off everything. That's the reason why I gave the 3 steps, because I think the easiest thing is most of us have the understanding that we should have acceptance criteria on our stories, but we don't really have a framework around it. So I think this BDD approach and the way we discuss and refine the stories to put the acceptance criteria using scenarios is a very easy thing to do. All we're asking people to do is not even change any of the normal operating procedure. We're just asking them to talk differently about the acceptance criteria and use a structure that we all agree on. So, from my experience and my coaching ever since that day, every team I coach is taught to use BDD scenarios as acceptance criteria. It's just what we do.
All right. Very good. Fantastic, Larry. I really want to thank you for your time and thank all the attendees for taking time from their busy schedule to attend this webinar. And thanks, Jill, for the introduction at the beginning. So I really appreciate all your time. And once again, thanks for attending, and see you all in our next month's live events. And we will continue our webinar from the month of September because next month we are going to do live events in Dallas, Austin, Houston, as I mentioned before. So we look forward to being in touch with you. So feel free to look us up anytime. And thank you all.